Okay, good morning. I can see that the number of students is decreasing by the day, but I can assure you that those people who are not attending classes are not getting marks also. Because I have the attendance, so I've been seeing. And now let's start off today's part of the syllabus. This is not going to be a long class. I just want to finish some portion. So we will be discussing power and Poynting vector. So as the name itself suggests, you know that electromagnetic waves, when they are traveling, they will carry information. Okay, that's something that you all know. They transmit information. Similarly, you also know that. Similarly, you also know that waves carry information and power. So today we are going to look at the power aspects of electromagnetic waves when they are propagating. So what we'll do is let us consider two of the Maxwell's equations. Okay, and when I'm saying two of the Maxwell's equations, I'm talking of Faraday's law. So this is Faraday's law, and the other is going to be modified Ampere's law. So both are curled equations. So take both these Maxwell's equations and then start working with the modified Ampere's law. Start with the Ampere's modified law equation. Do a dot product of E vector with the left and the right hand side. When you do a dot product, you're going to get E dot del cross H, and on the right hand side, you will get sigma of E dot E, sigma of E dot E, which is E square, sigma is E square, and then of course you get E dot epsilon dou E by dou T. Okay, the next line what we have done is we have just expanded the left hand side. When you expand the left hand side, you're getting H dot del cross A. I'm sure you know this formula, A dot del cross B. Okay, so that's what we have done here. So it is H dot del cross E plus del dot H cross E. Okay, and straight away you should be able to realize that you're going to get scalars on the left hand side of the equation. And on the right hand side again, it's going to be scalars only. Now go to the next slide. So here what we have done is the reason why I wrote this in red is because I'm going to use Faraday's law. Instead of del cross E, we are going to substitute minus mu dou H by dou T. Instead of del cross E, we are writing minus mu dou H by dou T. Okay, so that's what we are doing in the third step. And then in the next step, it is just reorganizing the terms. Like you see here, H dot, or you just take off this minus mu outside, and then H dot dou H by dou T. H dot dou H by dou T can also be written as half into dou H square by dou T square. So this half dou H square by dou T square, when you do dou H square by dou T square, you will get 2 into dou H by dou T. Right? So that's the reason why we are writing this step. Then the rest is as it is. Okay, now what we do is retain only this side, this term on the left hand side, and take everything else to the right hand side. Take everything else to the right hand side. When you take everything else to the right hand side, you see what you're getting. Sigma E square half epsilon dou E square by dou T, dou E square by dou T. Okay, and next thing is mu dou H square by dou T. Okay, and after that, what we are doing is we are doing integration over a given volume of space or given volume of the dielectric. So let's do an integral over a volume. So when you do a volume integral on the left hand side, you are certainly going to do the volume integral on the right hand side also. Okay, I hope this step is clear. Once we are done with this, okay, once we are done with this, let us see. So there's suddenly, okay, let's just go up. Then we have, okay. So you can see here that I made a small change here. So the small change is it was, go to the previous page. It was, if you go to the if you go to the previous page, it was H cross E. You know that H cross E is minus of E cross H. H cross E is minus of E cross H. So we're just going to do that here. Okay. And then because there is a minus sign, you want to get rid of that minus sign. So multiply both sides with a minus 1 so that the left hand side becomes plus and the right hand side will have minus. I hope this step is clear to you. So if you don't understand, I'll once more tell you what we have done. We have used H cross E is equal to minus E cross H. Okay. So we have just used this and then multiplied the entire equation with a minus 1 so that the left hand side becomes positive. And on the right hand side, you're going to have two negative signs. Okay, and then we are also putting together dou by dou t of epsilon e square and dou by dou t of mu h square were two different terms. Now we have just clubbed them together. And when you see these two expressions, you should remember something that you have studied in the past. These are expressions which are talking of energy density in an electric field and energy density in a magnetic field. Or these two are talking basically about when I do an integration over volume, we are talking of energy associated with the electric field and energy associated with magnetic field. And when I'm talking of dou by dou t of this expression, it means we are talking about time rate of change of energy associated with electric field and magnetic field. How many of you understood this? You have studied in physics U of E is equal to half epsilon E square. Similarly, energy density in the magnetic field is half mu into B square. I mean, B square by mu, you must have studied there. In physics, you have studied B square by mu. Okay, but you know that B is equal to mu H. So therefore, you can write it as half into mu H square. I hope you remember these two equations. Now, what are these two? These are energy densities. These are energy densities. Now, when you do a volume integration of energy density, what are you getting? You are getting energy. Okay, and then when you're doing dou by dou t of energy, you're getting rate of change of energy. Rate of change of energy is actually power. Okay, so that interpretation you should remember. So next what we do is, to the left hand side of the equation, apply divergence theorem. When you apply divergence theorem, instead of del dot E cross H dV, you will get integral E cross H ds dot ds. What is this surface? This is a surface integral. So S is the surface, enclosing volume V. Okay, so S is the surface that is enclosing the volume V that we are talking about. Okay, now comes an important step. We are defining E cross H. Can you see there is an E cross H here? We are defining E cross H and calling it as a vector P. We are defining vector P equal to E cross H. Okay, and look at the way P is written. It is written in italic style, capital P. Please follow this. It is italic style, capital P, and it's a vector. You can see it's a vector because E is a vector, H is a vector, and cross product has to be a vector. And this vector P is called the Poynting vector. It's called the Poynting vector. And what is the interpretation of P? The interpretation of P is that it is the instantaneous, see every word has got a meaning here. It is the instantaneous power density associated with the electric field at a given point. That means at every point in space it will have a value. Okay, it is the instantaneous. Instantaneous means what? At that instant of time, you're taking a small time interval dt, and then at that instant of time, at a point xyz in space, you're talking about the power density. I hope this is clear to you. Okay, so it's called the instantaneous power density. What is the unit of power? Power is watt, and we are talking of power density. So it's actually power radiating per unit surface area. It is power radiating, instantaneous power radiating per unit area. That therefore the unit will be watts per meter square. And what is this energy associated with? This is the energy associated with electromagnetic field. Any doubts on this? Anyone? Guys, these are small steps only, but then they all have a lot of meaning. We are defining what is this E cross H. E cross H is defined as a vector P written in italics. It is called the Poynting vector. and it will have a unit watt per meter square. What is power? So it is power radiated per unit cross-sectional area. But then what power? It is the instantaneous power at that instant of time. Or in other words, you will be able to immediately realize that this P is going to be a function of X, Y, Z and time. It is going to be a function of, because it's instantaneous, so it's going to be a function of X, Y, Z and time. Why is it a function of X, Y, Z? Because it is the energy density, power density associated with every point in space, every point that you are interested. And what is the point you are interested? The point lying within a volume V enclosed by a surface S. Okay. So now next step you see, so it is a closed surface integral over the surface enclosing the volume V. So integral P dot D is equal to, look at the right hand side, half dou by dou T of integral E epsilon E square plus mu H square and a volume integration. And the next is sigma E square dV. Okay, now this equation is called Poynting theorem. It is called Poynting theorem. Let us see what Poynting theorem says. Poynting theorem says that the total power flowing out of a surface enclosing the volume. When I do an integration over the surface, the entire closed surface, it is the total power flowing out of the surface. The total, maybe you should even add a word, total instantaneous power flowing out of a surface enclosing the volume is going to be equal to, so something is flowing out means where is it coming from? It is coming from the energy inside. I hope you remember what is the definition of power. You have studied power as, what is power? Power is rate of doing work. Power is rate of doing work or work done by time. I hope you remember. And what is the unit? What is the unit? It is joules per second. Joules per second is watt. Joules per second is watt. And similarly, you can also talk about it as energy change per time. So this also will have the same unit. You can talk about power as work done by time, or you can talk about energy expended by time, rate at which energy is expended. Okay, so we will see a mix up of these things here. So the left hand side you're saying is the total power flowing out of the surface, yes, that is going to be equal to, where is this power coming from? It is coming from the energy inside. So what is that? Where is it coming from? It is given by the rate of decrease in the energy stored in the electromagnetic field. What is this rate of decrease? The rate of decrease, dou by dou T. Dou by dou T is the rate of change. And why do we say decrease? Decrease because of this minus sign. That means energy is stored in the electromagnetic field, which is lost as a function of time, and energy loss as a function of time is power. And what is happening to that? It is coming out of the surface. So one contribution for this power is coming from the rate of change of rate of decrease of energy associated with the electric field and the magnetic field. Then there is something else also happening. All that energy is not actually happening. Okay, there may be a certain amount of energy in the electromagnetic field which ideally should have been coming out of the surface as power. Okay, but there is something else happening inside. What is that? There will be also ohmic power losses. There is a resistive element. You, like for example, your intrinsic impedance, that is a resistive element. Okay, so what happens is there will be ohmic power dissipation happening. I hope you remember when we were talking about mediums, we talked about lossy medium. And for a lossy medium, we said there is an intrinsic impedance. That intrinsic impedance is the factor that is responsible for the power loss. Okay, so here what happens is this power dissipation is an ohmic power dissipation. So the difference between these two is what is going to come out as power. I hope this equation is clear to you and the interpretation of this theorem is clear to you. So the total power flowing out of a surface enclosing the volume is equal to the rate of decrease of the energy stored in the electromagnetic field minus ohmic losses. Okay. Any doubts, guys? My God, everybody's understanding everything means I think I can go first. Okay, so Poynting theorem, we are writing it as an equation, as a statement now. So Poynting theorem says that the total power flowing out of a surface enclosing a given volume is equal to the time rate of decrease of energy stored in the electromagnetic field minus the ohmic losses. Okay, and another thing that you're seeing is P is after all equal to Poynting vector is equal to E cross H. Poynting vector is E cross H, therefore it will be perpendicular to both E and H. And in an electromagnetic field, you know what is perpendicular to E and H. What is that? That is a direction of propagation. That is a K vector direction. Where are we getting this from? AE cap cross AH cap is equal to AK cap. It's coming from there. Okay. So the P vector is a vector which is perpendicular to E and H. It is in the direction of propagation. Next, how do we get the P vector? Let us see. How do we get P vector? So for that, let us consider the most general situation. The most general situation is a lossy medium. For a lossy medium, let us take a wave which is traveling along the Z direction. Propagation is along the Z direction, and electric field and magnetic field are along the X direction and Y direction respectively. So let us write the expression for the electric field. So the electric field is going to be given by the electric field is going to be given by E naught e to the power of minus alpha z cos of omega t minus beta z along the x direction. Now write the H field. Now write the H field. When you write the H field, you see, you know how to write it for a lossy medium. It will be E naught by modulus of the intrinsic impedance. Again, e to the power of minus alpha z cos of omega t minus beta z. But the angular part of the intrinsic impedance will come into the equation. Therefore, there is a phase difference of theta eta, and always the E vector will be leading the H vector. Okay, so these two you know from the previous discussions. Now let us get the P vector. P vector is E cross H. Okay, now just multiply both these. Just multiply both this. So when you multiply both this, what will you get? You get E naught square modulus eta, then e to the power of minus 2 alpha z. Up to this is fine. Now, what we are next doing is cos A. If I call this as cos A, and if I call this as cos B. Cos A into cos B. You know the formula for cos A into cos B. Cos A into cos B is half into cos A plus B plus cos A minus B. We are just using that formula here. If we use this formula, you are getting that half. This half comes from that formula. Okay, comes from that formula. And next, cos of A plus B, cos of A minus B. So you're getting two terms now. Two terms. One is cos theta eta, the other is cos 2 times omega t minus 2 times beta z minus theta eta. Okay, and direction is along AK direction. Is this step clear? And you can also see a pictorial representation of Poynting theorem. Poynting theorem. Energy is stored in the electric field here, energy is stored in the magnetic field indicated by an inductor and a capacitor. And these are the stored energy, and it is losing energy at a certain rate. And then all the energy that it is losing as a function of time is not coming out as power. Some part of it is lost as ohmic losses. So these three things have been given in the form of electrical elements. You know that ohmic losses are always associated with resistors. Similarly, electrical energy is associated with a capacitor, and magnetic energy is associated with an inductor. So that's the pictorial representation shown here. Okay? Any doubts? Okay, if there is no doubt, let's just go ahead. Now, how is this Poynting theorem? What is the origin of Poynting theorem? Poynting theorem originates from the concept of conservation of energy, and in this case, conservation of electromagnetic energy. Okay, so electromagnetic energy, you have studied in LCR circuits in physics and even in electrical sciences that energy can oscillate between the electric field and magnetic field, that you have studied there. And similarly, you have also talked about LCR circuits where there is energy losses because of the resistive elements. So same ideas you can just borrow for electromagnetic fields also. Okay, so it is a consequence of energy conservation in electromagnetic. Okay, now we are going to see two other definitions. Two other definitions. What are those two definitions? Let us see. We have seen Poynting vector. Okay, next we will see what is called time average Poynting vector. Time average Poynting vector. Poynting vector was instantaneous power. So if you want time averaging, what should you do? You should do an averaging, and you should do an integral over the entire time period. You have to do a time integral over the entire time cycle, the time interval for a time period. Okay, so and then divide by the time period. So that is your mathematical definition of time average. This I'm sure you all studied in mathematics. So let's just do that. So P average. P average is going to be a function of position only. It is not going to be a function of time. Why? Because you have averaged for a time cycle, for a given cycle. So it is 1 by t and integral 0 to t p dt. P dt. Okay, when you do P dt, let us just go back to the previous page and see what you will get. You had this E naught square by 2 modulus eta e to the power of minus 2 alpha z. All of them are constants. They come out of the integral. All of them are constants. They come out of the integral. But what else was left? Do you remember? You had two terms were there, cos theta eta and cos of 2 omega t minus 2 beta z minus theta eta. So you're going to have two integrations. You will have two integrations. So what are the two integrations you will have? One integration is going to be integral cos theta eta dt. This will be 1. Okay, and then of course you have a 1 by t. What will be the other one? The other integration will be 1 by t integral cos of omega t minus, what is that? Let me see that again. It is 2 omega t minus 2. Let me write it. So it will be 2 omega t minus 2 beta z. Then I think you had a plus theta eta into dt. Okay, now you can see that when you integrate this, you will get a 0. From mathematics, you know that if you do an integration of a cosine function or a sine function for a full time period, the answer will be 0. Why is the answer 0? The answer is 0 simply because you know how a cosine function or a sine function will look. This is one cycle. This is one cycle. The positive area is going to be equal to the negative area. Therefore, the average is going to be equal to 0. This is true for both a cosine function and a sine function. But I'm sorry. I just need to just go back a bit. One sec. The first term will not give you 0. First term will not give you. Second term will give you 0. The second term will give you 0. This will give you 0. Why will this give you 0? Because this has got a time component. So you can actually do an integration, and a cosine function or a sine function, when you do an integration, will give you 0. I hope that's clear. But come to this fellow. When you come here, theta eta is a constant. So cos theta eta is going to be a constant. So when you do this integration, you will get 1 by t into t, okay, t you will get. Okay, 1 by t into t, and this cos of theta eta will be a constant, it will come. So what are you going to get? You will just get cos theta eta. So that's what you are seeing here. Ben, are you listening even?
Yes, ma'am.
Huh?
Not paying attention.
I'm not paying attention. I am an idiot here. Sanjana, are you listening? From next class, I'm going to only record and give you, man. I'm not going to take classes. See how these terms have come, I have explained. Your book is not going to give you all these answers. Okay, now, so this is the expression for average Poynting vector. Okay, next, there is a third definition we are going to talk about. What is the third definition? The third definition is the total average power. So look at this one. This is the average power density. This is average power density. But now we are going to talk about total average power crossing the total surface area. So for that, what should you do? When you say power density, it was average power crossing a unit cross-sectional surface. But when we want for the total, what should you do? You have to do a total surface integration. So when you do that total surface integration, you get average power. It is not power density anymore. It is average power. Unit will be watt. And you get it by doing integral uh, power density average dot ds. Why dot ds? Because your s vector, your ds vector and your average power vector will both be parallel to each other. Okay, and they will be radiating out of the surface. So now what we are concluding finally is Poynting vector will be a function of x, y, z and time. Okay, unit will be watts per meter square. It's a function of space and time. Now come to average. Average power density will be a function of just x, y, z. Time is not there because we have averaged over a time cycle. And it is an invariant quantity. Invariant because time is no longer there. Then last part is power average. Power average, you see, italics we are no longer using. It is the total average power, total time average power through the surface, and the unit will be watts. Whereas for the other two, the units will be watts per meter square. Now let me quickly do two problems to wind up this part of the syllabus. So the first problem that we are going to do is in a non-magnetic medium. Non-magnetic means mu equal to mu naught. You are given E vector. Find epsilon r and eta. So that's the first part of the question. So you can see that omega, you know that the propagation speed is omega by beta. So let's just substitute. Omega is going to be 2 pi into 10 to the power of minus 7. Okay, and beta is going to be 0.8. Okay, and you know that u is also equal to 1 by under root of mu epsilon. Okay, or in this case, I can write it as 1 by under root of mu naught epsilon r. Okay, or I can write it as 1 by under root of epsilon r, and then I'm left with 1 by under root of mu naught epsilon naught, which is c. Okay, so now you can get your under root of epsilon r. So what will be my under root of epsilon r? Under root of epsilon r will therefore be equal to c into 0.8 divided by 2 pi into 10 to the power of minus 7. Okay, so that would imply that epsilon r is going to be equal to, I've done the calculation for epsilon r, it is 14.6. Okay, so that's the way you're getting epsilon r. Then the next thing is you have to get your eta also. You have to get your eta. And please look at this. This is a, you can see that this medium, the medium is lossless. The medium is lossless. The medium is lossless because e to the power of minus alpha z is missing. This is missing. Okay. Therefore, you know that the medium is lossless. If the medium is lossless, that would mean that eta is real. Eta is real. Theta eta is 0. Okay. And for a medium like this, you know that eta equal to under root of mu by epsilon. Okay. Which will be under root of mu naught by epsilon r epsilon naught, or 14.6 into epsilon naught, which is 1 by 14.6 into under root of mu naught by epsilon naught. You know the value for this. It is 120 pi. Okay, so it is 120 pi divided by 14.6. So that's your eta. Okay, so you have finished the part A of the numerical. Now let us find out part B. So what is part B? Part B is finding out the time average power carried by the wave. To get the power average carried by the wave, what you need to do is you have to get your Poynting vector. Poynting vector you know is E cross H, right? E cross H. Theta eta is 0. So therefore you can write it as E cross H will be simply E naught square by modulus eta. Okay, E naught square by modulus eta, and then there is a sine omega t minus beta x. So square that. So you will get sine square omega t minus beta x, where omega is 2 pi into 10 to the power of minus 7 and beta is 0.8. And what is going to be the direction? Direction is going to be along the x direction. Look at this. There is an x here. So it is going to be along the x direction. So that's the direction of propagation. Okay, so the wave is propagating along the x direction. Okay, once we are done that, we want power average. Power average. Power average, you know, is 1 by t into integral of power density, instantaneous power density dt. I'm sorry, t is not a vector, dt. Okay, so when you dt. So when you do this, okay, you're going to get E naught square by modulus eta, and please remember square of, I told you sometime back that uh, for a cycle, integral sine theta d theta is equal to integral cos theta d theta is equal to 0. But when you do for sine square, it is not going to be 0. When you do for sine square, what happens is, look at this, sine square will be like this. Okay, so it will not average out to be 0. Instead, it will give you a half. It will give you a half. So you get half, and then of course your ax cap. Substitute for E naught. E naught is 4. Eta you just calculated. Okay, put everything. I will give you the answer. The answer will be 81 along the ax cap direction. Units will be watt per meter square. Okay. Now once we are done with that, let us go to the C part of the problem. This is slightly tricky. Please follow. What is the C part of the problem? The C part of the problem is finding out what is going to be the total power crossing 100 centimeter square of a plane defined by 2x plus y equal to 5. What is the total power crossing a plane area 100 centimeter square, and it is defined by the plane 2x plus y equal to 5. Okay, so how do you do that part? So to do that part, let us see what we have to do. So to do that part, what we will do is, let us consider, okay, so the total power crossing. Okay, so first of all, let us write the S vector. S vector is the area that it's crossing. So it is 100 centimeter square. I think it's given as centimeter square. So convert it into meter square. So 10 to the power of minus 4 meter square. And what is the direction of this? Look at the equation for the plane. So the plane is given by 2x plus y equal to 5. Okay, so what will be the direction of a unit normal? What is the direction of a unit normal to this plane? The direction of the unit normal to this plane from mathematics is 2ax cap plus ay cap divided by the modulus of this. So that's under root of 4 plus 1, so under root of 5. So this is going to be your an cap, where an cap is the normal to the surface. normal to the surface. And look at the plane of the surface. The plane of the surface is xy plane. Therefore, I can say that this is your, if this is your xy plane, I hope this is xy plane. Yeah, if this is your xy plane, then the propagation direction is going to be perpendicular to this. Perpendicular to this. So now let's just go ahead and do this. So the total power. So the total power is therefore going to be equal to P average dot ds okay, and you can straight away see that this is going to be equal to P average into the S vector, which is P average into S. Okay, P average into S. And you've seen that P average, what was P average? I should not, before writing this, let me write one more step. So let me write what is P average. So P average we have done in the previous step, it was 81 AX cap, okay, dot, what is our S? S is 2 AX cap plus AY cap by root 5. So that means there is a contribution only from this. Okay, so therefore this will be 81 into 2 by root 5. So only this will be there, and the unit, I have done the calculation, it is going to be 724.5 watts. So that's the answer for the total power crossing, total average power crossing that 100 centimeter square, having a direction given by A and K. Okay, once I've completed this problem, let's go to the next problem. So the next problem is a much shorter problem. Okay, you can see that you need your good mathematics skills to do all these problems. So that's all you require. So we are talking of free space. So what is free space? Free space is mu naught epsilon naught sigma equal to 0. So in free space, H vector is given to you. Then find the total power crossing through a square plate of side 10 centimeter. So let's do this. So S vector in this case is going to be 10 square. 10 square is 100 and it is centimeter square. So 10 to the power of minus 4 meter square. And what is going to be the direction? The direction defined by x plus z equal to 1. X plus z equal to 1 is the plane. So how do I write my unit vector? The unit vector now will be written as 1 by under root 2, then a x cap plus a z cap. Okay, so this is going to be my S vector. So now as usual, we have to write our P. Okay, you have to write our P vector. Poynting vector is going to be E cross H, okay, which is going to be 0.2 cos omega t minus beta z ay cap cross 0.2 by modulus eta. Modulus eta is going to be 120 pi. It is 120 pi. And then you have cosine of omega t minus beta z. There is no theta eta, but the direction is going to be, you have to just use AE cross AH equal to AK. Okay. So when I use that, so this is going to be equal to A, you have the magnetic field. Sorry, there is a small mistake here. What we have is the magnetic field, not the electric field. When I did the problem at home also, I made the same mistake. So first let us write the electric field. The electric field is going to be 0.2 into 120 pi. Why into 120 pi? Because E naught is equal to H naught into modulus eta. Then of course you have to write cos of omega t minus beta z, and what will be the direction of the electric field? Direction of electric field will be ay cap using that cross multiplication, and then cross, you write your H vector. H vector is 0.2 cos omega t minus beta z. So of course E cross H. Therefore your AE is going to be AX. Wait. So AE cross. So therefore, this is going to be equal to, one of them is going to be AZ. AZ, and this is going to be AY as given there. Okay, therefore your answer, I will tell you, when you do the multiplication, your answer will be 0.2 whole square into 120 pi into cos square omega t minus beta z, and the direction will be ax cap. So this is going to be your Poynting vector. Okay. Then once you get your Poynting vector, what should you do? You have to get your power average. So how do you get your power average? Power average is 1 by t integral p dt. Okay, when you do that, you will get 0.2 square, you will get as it is, then 120 pi you will get as it is, but then you will get a half, you'll get t by 2. So t and t will cancel out, so you get a half. So this is going to be your P average. It will have the same direction, Ax cap. Next, you want your total power, total average power. So total average power is going to be integral P average dot ds. Okay, so we can see it is going to be integral 0.2 whole square 120 pi by 2, and then it's going to be ax cap dot ds is 1 by root 2 ax, sorry, there is no integral, because when you do the there will be just into only, dot product only will be there, so integral is not there. Okay, so you get ax dot ax cap plus az cap. So only this will contribute because this part is also having ax cap. Therefore, you do the dot product and then you will get an answer 53.3 milliwatts. Okay. Similarly, what I want you to do is for a circular disk defined by the plane z equal to 1, do the same thing and see. Okay. So with this, we are completing energy transmission, Poynting vector, and power calculation. So that part is over.
Ma'am, here the wave propagation direction is Z, no, ma'am.
Wave propagation direction is one sec.
Because
One sec.
then only we can have.
Wave propagation direction is Z. Okay, you're right. So what will happen? One sec. Let me just correct it. Wave propagation direction is going to be Z E cross. So this is AY. I think I'll have to write everything. So
E
AE.
will be in X direction.
E will be X direction. Okay, let me just
Yes.
correct that. So what is the correction I have to do? E will be in X direction cross AY. So therefore here you will get AZ. So AZ, and then here also it will be AZ. Answer will not change because it's going to be this AZ and this AZ, and 1 by root 2 is going to be there. So answer will be 53.3 milliwatt. Okay, now I have done two problems which are both lossless. One is free space and the other is a lossless medium. But when it is a lossy medium, you have to use this particular equation. You have to use this particular equation. It's a lossy medium. Theta eta will come into picture. Theta eta was not there for the others. And you know that cos 0 is 1. So that's the reason why you are not seeing that in the two problems that I have solved in the class. Okay. So with this, just go through it, I'm sure, because all the intermediate steps where there can be confusions, those things have been discussed. So I don't think you should have any problem working out. Okay, so maybe I just have to write something here. It's going to be 2ax cap plus ay cap by root 5. So that's the direction. Okay, otherwise it's fine. So next class, what I have to do is I have to start with two medium. Okay, and what will happen to a wave that is hitting the interface of two medium. Actually, that is interesting only, but it requires a lot of three-dimensional imagination. Okay, I hope by then you are finishing your test and all that, and you will come with a peaceful mind. And please, this kind of attendance, if it is continuing, I will do what others are doing. I will simply record and give it to you, and I will not come to class. Because it's very, see, and I'm telling you, mood of a teacher is so important while taking a class. I came to the class with a very nice frame of mind, but after looking at these numbers, I don't feel like taking a class. And I ask whether you have understood, nobody is even responding. Well, then I will also go fast. What is there for me? I can also finish the syllabus without any effort. And another thing, I just want to give one clarification, guys. I use the word watermarking. Watermarking is a word used to suggest that we are employing something to see that students are not copying. Okay, so that's the meaning of watermarking. Don't go with the computer watermarking. Don't do that. I don't want that. That can be manipulated. Please don't do that. Instead, use a red pen. That's the reason why I'm deliberately saying use a red pen across the diagonally across the page. Please write your number in big letters. And over that, you write your answers. Nothing will happen. I need that. Without that, I will not correct because I have done everything because we have been given the freedom to ensure that cheating is not there. I have used my own method and I have communicated the same to the director and to the academic wing also. So I will be well within my right to not evaluate your paper if you don't listen. Next thing is 3 people will be monitoring, will be doing the monitoring of your writing. So please ensure that your camera is on at all times. You are writing, your desk and your face are seen. I am not doing anything new. This is being done at the university level, and this is the advice given by the university. And you know that I am a stickler to rules. I am following it. That's it. Because I'm not compromising with my teaching. So when I'm not compromising with my teaching, why should I compromise with discipline? Any doubts you want to ask for the test? Don't waste your time searching the internet. That is my advice. Okay, looks like nobody is there to even ask for a doubt. Okay, all the best.